Welcome to NIOS live classes. Subject: Science and Technology. Book number 212, Module number 2, Matter in our Surroundings. Lesson number 3, Atoms and Molecules. Part 1. We are going to learn what is atoms and molecules. In general, we can say every single thing has atoms in it. For example, when different atoms combine, they become molecules. For instance, we can take water, which is H2O. It has 2 atoms of hydrogen and 1 atom of oxygen, and combining them we get the molecule of water, which is H2O. Introduction. Long ago in India, people talked about whether matter can be divided again and again. An Indian thinker named Maharishi Kananand, he said that if we keep dividing matter, we get smaller and smaller parts of it. There is a picture showing Maharishi Kananand. He said that at one point we cannot divide it any further. These smallest particles were called Parmanu. Then Pakudha Katanan said Parmanus joined together make different matter. At the same time, Greek thinkers, one is Democritus and second is Lysippus, gave a similar idea. They said that matter is made up of very tiny particles that cannot be divided any further, which is called atoms. Outcomes. After study this lesson, learner will able to know some points. First, they can state the law of conservation of mass and law of constant proportions. Second, they can list important features of Dalton's atomic theory. They can distinguish between atoms and molecules. Three point 1 Laws of chemical combinations. There is showing an example of carbon oxide. One atom of carbon and second two atoms of oxygen combining CO2. Beginning of modern chemistry. After the 18th century, chemistry made great progress. Scientists became interested in studying heat and burning. In short, we can call it combustion. They started using balances. As you can see on the screen, they started using these balances to measure how mass changes during chemical reaction. There is a person, Antony Lavoisier. He stated the law of conservation of mass. Antony Lavoisier, a French chemist, he studied reactions carefully using a balance. In his study, he heated mercury in air inside a closed flask. After a few days, that mercury becomes the red substance which is called mercury oxide. There is a picture showing how mercury exchanged in mercury oxide. During that mercury burning, the air left in the flask lost some mass and could not support life or burning. That lefted air was nitrogen. The gas that combined with mercury was oxygen. And when mercury oxide was heated again, it broke down into mercury and oxygen. In short, we can say HgO, which is mercury oxide, it broke down in mercury, which is Hg, along with oxygen, which is O2. mass of mercury and oxygen was equal to the mass of mercury oxide taken at first. In form of formula, we can say mass of Hg, which is mercury, plus mass of oxygen is equals to mass of mercury oxide, which is HgO. Lavoisier conclude that mass is neither created nor destroyed in a chemical reaction. This is the call of law of conservation of mass. There is another scientist, Joseph Proust. He stated the law of definite proportion in 1808. Joseph Proust, he showed that a chemical compound always has the same elements in the same fixed ratio by mass. It does not matter how or where the compound is made, the ratio stays the same. This is called the law of definite proportion, or we can say law of constant proportion. For example, in pure water, the mass ratio of hydrogen to oxygen is always 1:8. Water always has 11.11% hydrogen and 88.89% of oxygen, and it doesn't matter if it's from a river, a pond or a well, etc. For instance, when 9 gram of water is broke down, it gives 1 gram of hydrogen and 8 gram of oxygen. And when they combine, they gave us 9 gram of water. Same, if 3 gram of hydrogen and 8 gram of oxygen are combined, they form 9 gram of water with 2 gram hydrogen left unreacted. Next, if we talk about common salt, which is NaCl, it always has 39.34% of sodium, which is Na, and 60.66% of chlorine, which is Cl. Whether from sea or water, salt mines, or made in a lab. But the important word here is the pure compound. Now we are going to learn what is Dalton's atomic theory. John Dalton was not the first to talk about atoms, but he explained old ideas clearly and gave proof that atoms really exist. He used his theory to explain important science laws like the law of conservation of mass and law of constant proportion. Dalton's main idea, he gave his idea in 1803. All matter is made up of very small particles, which is called atoms, and atoms of the same elements are exactly the same in mass and proportion. Atoms of different elements are different in mass and properties also. And they cannot be destroyed or made again during a chemical reaction, but they can only rearrange. Compounds are made when atoms of different elements join in simple whole number ratio. Connections with science laws. Law of conservation of mass. Atoms don't change their mass in reaction, so total mass stays the same before and after a reaction. For example, there is an example of law of conservation of mass. There is a log and fire. After burning the log, we get the ashes and smoke. Log was weighted 30 kg and fire was 1 kg. So, after burning, we get the ashes and smoke. Ashes was weighted 28 kg and smoke was weighted 3 kg. So after and before, the mass was same, which is 31 kg. Same as for iced water and liquid. Let's take a short break. Welcome back to our classes. Now we will look what is law of constant proportions. Compounds always have the same kinds and numbers of atoms. So the mass ratio of element is always stays the same. For example, water molecule, which is H2O, it has 2 hydrogen atoms and 1 oxygen atoms, and they became the one molecule of water. Next is law of multiple proportions. When two elements form more than one compound, the amount of one element that combines with a fixed amount of the other is in simple whole number ratio. Example: carbon and oxygen can join together in two different ways to make different compounds. For example, first is carbon monoxide and second they can form carbon dioxide. When scientists measured how much oxygen combines with the same amount of carbon, they found in carbon monoxide 1 gram of carbon joins with the 1.3321 gram of oxygen, and in carbon dioxide 1 gram of carbon joins with 2.6642 gram of oxygen. Now let's learn what is an atom. An atom is the smallest fundamental particles of matter. Atoms of different elements have different sizes and weights. For example, atom of gold weight heavy and atom of water weight lighter. It may or may not exist independently. An atom can sometimes exist freely on its own, such as noble gas, like helium and nitrogen, and sometimes it does not exist alone, but it combines with other atoms to form molecules such as H2O, CO2, but it always takes part in chemical reaction. Whenever a chemical reaction occurs, atoms are always involved in it. A chemical reaction is not possible without an atom. Short example, a hydrogen atom rarely exists alone, but during a reaction it combines with oxygen to form water. Now we will look what is the size of an atom. Atoms are nearly spherical in shape. They are extremely small or too tiny to see or imagine. They cannot be seen even under high-power microscope. For example, 1 teaspoon of water has more atoms than the Atlantic Ocean has teaspoons of water. Another example, one teaspoon of water has more atoms than a glass of water. Now there is a picture showing the structure of an atom. In center there is a nucleus. And outer it has a layer. On it electrons are moving. Nucleus include protons and neutrons. Protons has positive signs and electron is negative. Even million of atoms stacked form a layer only as thick as sheet of paper. Atoms of different elements vary in size and mass. Everything around us is made up of an atom. Whether it is gold, copper mug, koila or balloon. Shape of an atom. Scientists find it difficult to imagine the real shape of an atom. But for practical purposes, they consider it spherical. Spherical, round like a ball. Measuring atom sizes. Since atoms are very tiny, we use special units For example, we use kilometer for measuring the road or the distance. We use centimeter to measure the small things, and for atoms we use special unit which is called nanometer. 1 nanometer equals to 10 its power minus 9 meter. There is a nanometer scale which is showing how bigger an atom of a substance is. For example, a DNA atoms, etc. Let's take a short break. Welcome back to our classes. We have studied that atoms are extremely small or tiny. You can understand their size by comparing them with bigger objects. There is a table showing the relative sizes. Atoms of hydrogen it has combined with the grain of sand, ant, watermelon, etc. You cannot see atoms with your eyes because they are extremely small, but today Scientists use special modern tools to view them. These tools can create magnified images of the surfaces of elements. These images show individual atoms clearly. This technique is called scanning tunneling microscopy. STM, scanning tunneling microscopy. It is a very sharp metal tip moves slowly over a surface. When the tip comes close to an atom, a tiny electric current starts to flow between the tip and the surface. This current is called tunneling current. Atoms are too small to see with normal microscopes, but this tiny current changes depending on how close the tip is to each atom. By measuring these changes, scientists can make picture of an atom. It is similar to reading Braille, where you don't see letters but you feel bumps with your fingers. There is a picture showing STM process. It's explaining how scientists draw a shape of an atom through a current. Atomic mass. Atomic mass is the weight of an atom. Dalton introduced the idea of atomic mass. He said that every element is made of tiny particles called atoms. He said that atoms of the same element have the same atomic mass, and also that atoms of different elements have different atomic mass. Each element has its own kind of atom, and each kind of atom has its own weight. This weight is called atomic mass. In short, we can call it Am. Dalton could not weigh one atom because atoms are too small. So instead, he compared the masses of elements that joins together to make a compound. There is a picture showing Dalton's atomic theory. One oxygen atom at 16 mass unit each and two hydrogen atom at 1 mass unit each. So one water molecule at 18 mass units each. Dalton used these weight comparisons to find relative atomic masses, which means how heavy one atom is compared to another. For example, 1 gram of hydrogen reacts with about 8 gram of oxygen to make water. We know the formula of water is H2O, including 2 hydrogen atoms and 1 oxygen atoms. This shows that one oxygen atom is much heavier than one hydrogen atom. In simple words, we can say by comparing the weights of elements that joins together and using the formula of the compound, Dalton found relative weights. But he did not know how many hydrogen and oxygen atoms join to make water, so he made a simple guess that one hydrogen atom combined with one oxygen atom. Because of this guess, he thought that one oxygen atom is about 7.9 times heavier than one hydrogen atom. Later, scientists found that this guess was wrong because water is actually H2O, including 2 hydrogen and 1 oxygen atom. We now know that water has twice as many hydrogen atoms as oxygen atoms. Its formula is H2O. We have completed our lesson. Thank you for paying attention.